we started FM4, credit and borrowing. We started it by looking at flat rate loans. And I hope you remember, because it was only a couple of weeks ago, I hope you remember that when you see the word, or the phrase rather, flat rate loans, you think back to all of the financial maths that you did earlier in the year and in year 9 and 10, and you should think simple interest, right? Once you've got simple interest in your mind, you're like, ooh, I know what the simple interest formula is. It is I equals PRN, right? So you're like, okay, this is cool. This is not hard, no problem. So we started FM4 looking at flat rate loans. We're going to end FM4 looking at this thing called present and future value. These are the abbreviations we use: present value, future value. And in a very similar way, when you see flat rate loans, you think simple interest. When you see present and future value, you should think compound interest. Okay, so this is not crazy new stuff, but it is phrased in a different way. The language of the questions will be just a little bit off at an angle, and we know in Mathematics General and as in real life, the way you interpret things is actually sometimes the lion's share of the question. Okay, so I want you to remember with me, compound interest, I should have kept this color, just like simple interest, has its formula. I'll give you a tip. It starts with an A. This is for compound interest. What's the rest of it?
Is it P in brackets 1
Yeah,
plus
very good. P brackets 1 plus
and then n power of n.
Very good. Okay, so you remember this, and you've got your formula and data sheet sitting in front of you. So hopefully it's you'll actually see it there. Where we go on the first page, it immediately follows the simple interest formula. Okay. Now I want to point out two things. Firstly, just to jog your memory, when you have a look at the right-hand side of each of these formulas, when you look at the right-hand side, you can see it's got the same 3 pieces of information. Do you notice that, right? It's still got the principal, it's still got your interest rate, and it's still got N, which is, what is N? Number of compounding periods, right? Or, yeah, periods is a better way to say it. Okay, so 5 years, 60 months, whatever it happens to be. Okay? But one thing that's very, very different is that here, the simple interest formula calculates the interest for you. So do you remember we were looking at some questions last time, and it's like, what's the total value that I have to pay off for something? And you can go ahead, you can work out the interest, but then you've got to add back to that the principal. If you got like a credit card debt and you're paying off the whole thing, there's principal, there's interest, you work them out separately, you combine. Whereas this guy over here, this formula includes A. What do we usually think of A standing for? Amount, usually. So put some arrows here for me, because this principal, right, this is where the account starts. Oops. Bless you. This is the value at the beginning, right? And then the amount, like you just said, is where the account ends. So you can see, built into this formula is kind of like the passage of time, right? You start somewhere, you end somewhere, and that includes the original amount and the interest that you've added onto that. Okay? So all we're going to do to change the language of this into this present future value business is that note that where the account starts, that's the present value right now, and where the account ends, that's the future value, what it's going to be. Okay? So I'm just going to rewrite this same formula. This is the future value over here, FV, where the account ends. This is going to be what you are right now, present value, PV. And then because it operates on compound interest principles, it's exactly the same thing over here, right? Which is why when you have a look at your formula data sheet, directly underneath the compound interest formula, there it is. Have a look on the right-hand side. You'll notice 2 that have FV and PV together. I'll talk about both of them in a second. But just have a look at the right-hand one. Do you see it? That's what it is. It's all it is. It's just dressed up very, very slightly differently. Okay. Now, what this formula lets you do is if you know the present value and the interest rate and the number of compounding periods, then you can work out what you'll be in the future. Okay. But sometimes we want to do planning, right? It's like, ooh, I want to save up to have this, or I want to be able to work out, can I pay off that loan in the future, right? So sometimes I don't want to know, discover, solve what the future value is. I know what this is supposed to be, and I want to find out this. So what we do is we just rearrange this formula ever so slightly. If I divide both sides by this 1 plus r to the n thing, okay, if I divide the left-hand side and the right-hand side, what's going to happen? On the left-hand side, I'm just going to get fv on 1 plus r to the n. So it's going to sort of hop over there on the left-hand side. And when you divide this, it just sort of goes away. Do you agree with that? So it just becomes pv. So you can see this formula, it's the same formula, it's the same idea, but it's like, hey, if I know what the future value should be, and I know what the interest rate is, and I know how long I've got to get there, then I can use those three things to work out, well, how much am I going to need to invest? How much am I going to have to start with? And these two here are what you find on your formula and data sheet. So they're not two different formulas. In fact, they're not even a new formula. It's just the previous formula, the compound interest one, just stated in slightly different language. Okay, does that make sense? Yeah? Okay. Let's quickly do two examples just to jog your memory on how this works. So here's example one. I want to draw your attention to, I'm going to do sort of like an exam technique thing here. I'm not just going to show you how to solve the question. I want you to think, what do you think is the easiest part of this to get wrong? What do you think is the most common error that students make on a question like this? Okay, and you all identify it because we've all done this before, right? You go through this, you're like, cool, I know how to go through this formula, I see what the rate is, I see what the amount of time is, and then you just punch them straight in, okay? So we don't slow down and realize, wait, this means, and we should all underline this means I've got to do something differently. So here's my exam technique to try and overcome that. The first thing I do before I launch into the formula, because I know as soon as I start down this path, my brain just kind of goes on autopilot and I stop thinking, okay? The first thing I'm going to do is I'm going to think about time, okay? So the first thing I want to know is, okay, compounding periods, and how many are there, right? So what's the number of, in this instance, the compounding period is a month. So what's the number of months that's actually going to elapse, going to pass in the time span of this question? It's 24, right? So I'm just going to write down 2 times 12, 2 years, 12 months per year. That gives you that number. And then along with the number of months, I want to know the interest per month. Because as you guys recognize, it's not just the n that changes, the r changes along with it, right? So instead of getting 0.08, it's going to be divided by 12. Very good. Okay. Now, if you go ahead and you put that into your calculator, I think it's going to hand you this. Okay. So that number there, 0.0666 repeater or something like that. Okay. That is our rate per month, and this is how many months I've got. Okay. So now that I've sorted that out, now I'm going to find out the value.
So can you just do, can you do 0.006666, or can you do 1 over 100?
Okay, so the reason why I've written it like this, rather than as this,
6666.
it's another 0, isn't there?
Oh, yeah, 0.
Yeah. Is because I'm about to pop this into the calculator, right? And I can't put this into the calculator. I can't type 6, well I can, but I don't want to type it forever. This is a lot faster to write. Sometimes, as you'll see in the next question, you get a decimal and it doesn't recur, it just stops. In which case, well, you might as well just write that. It's nice and easy to input into your calculator. So it's just a practical reason. Okay, so now I'm gonna go to work out with my present and future value formula. I want the future value, and I know the present value. It's right there, $25,000. Okay? So I'm going to go 25,000, 1 plus. Here's what I've calculated the rate to be, each compounding period. And here is how many compounding periods there are. Okay? Now just on the side here, you don't need to write this, but if you're in a hurry and you feel confident with this and you can demonstrate, yeah, I know what I'm doing with this. At this point here, like you don't have to do this as a separate step. You could write this all in one here, right? 25,000, 1 plus, there's the interest, and you see I've included months in that. And then here is the number of months in total, right? So do you see how I've sort of chucked all of these steps into here, okay? Now the reason I put this on the side and in red and asked you not to write it is because when we trust ourselves to do this all in one hit, we forget, we don't do it, right? And this is a common error, and you come back and you look, you're like, man, I knew to do that, and I was just rushing through. Okay, so as an exam technique, making a whole step out of this and getting into the rhythm of time, value, that helps you get the hardest part of this question correct. Once you've done that, whichever road you go by, you punch it into your calculator and out pops a number, which is?
2,932.
29,000?
Oh, sorry,
29,000?
322.
322 and?
0.19829. So round into 20.
Okay, so now I'm going to round. Okay, cool. And by the way, that's a perfect moment to remember, like this is an easy way to see, does it make sense or not? It's future value, it should be growing. So if I get 2,100 because I've like just fumbled some buttons on the calculator, I know something's gone wrong because I hope my bank account, like, wow, that's really bad inflation or something. Yeah.
So compounded quarterly would be every three or 4 months. So that was very confusing.
Yeah, that's a great question. So why don't we just have a look at this and say if we adjusted it rather. Quarterly means there are 4 quarters in a year. 4 quarters in a year. So therefore, I don't even need to think about, like, is it 3 months or is it 4 months? I just think about here, the number of quarters is going to be not 2 times 12, it'll be 2 times 4, because that's what a quarter means, right? There are 4 of them. So there will be 8 quarters in total. The interest per quarter will be 0.08 divided by 4. The advantage of doing it that way is you can do that with any kind of timescale you like. Like, if you had some weirdo crazy bank which is like, we compound your interest, once every 19th of a year, you're like, how many days is that going to be? I don't care. I just change this to be, 2 times 19, and I change this to be 0.08 divided by 19. It just doesn't matter really.